computer. Okay, we're now recording. So far, we've talked about the fact that this problem is a match pairs design. And in match pairs designs, you find the differences between the values in each observation. So one minus the other. So x minus y for us for each pair. Use those differences as your data. The way to create them in the calculator is to put in the x's and y's in the two lists, and then type this. The list the x's are in minus the list the y's are in, and store that with a little arrow. The arrow's down here above the on button. Store that in list 4. I've done that. We have here in list 4 the differences. So 18.5 minus 18.3 is 18.2, and down we go. I see some more negative ones than positive ones, but not that many more. And I don't know if that's enough to pull us away from 0 as a mean. We're going to find out. Okay, so I did part A. Compute the differences, check. B, compute D bar and SD. So I'll go to stat calc, one variable, and now I have to remember I'm in list 4. Do that. So it says x bar is minus 0.2 and s is 0.52. I'm going to go 526 like that. And as test the hypothesis, do you think the mean, long-term mean, is different from 0? So for C, you would go H0. My pen is not happy. That's not good news. This one. You'd think I'd have enough pens to cover the universe here. Let's try this one. So is that working? Yeah. HU says the mean of the differences is 0. And HA ought to be the mean of the differences is not 0. So we're going to see if we can do that test. The test statistic is T. It'll be x bar minus 0 over S over root n. We'll get that in a minute. And the degrees of freedom here is 1 less than the number of pairs. So 7 minus 1 is 7 minus 1 is 6. And we'll just compute this, see what happens. So x bar was negative. You know, on your calculator, if you want to do negative, you have to push this little button down here, this little baby minus sign. Otherwise, you're subtracting and it gets mad. Okay, so negative 0.2 divided by, and then I'm going to need parentheses because I'm dividing in the denominator. So S was 0.526. We're going to divide that by the square root. N was 7. There it is. Oh, see, there's a 4 in there. How do you like that? Make it a 7. Is it happy now? Let me get out of here. Okay, so negative 0.2 over 0.52 right here, 0.526. Okay, I'm going to zoom out a tiny bit. There it is, okay. So I'm hitting enter. Minus 1.005. So minus 1.005 for that. And we kind of have a feeling that the T is like Z. In order to reject the null hypothesis, you need something like a 2. We don't have it. And plus, we've got this level of significance, 0.01. That means you have to have a much bigger value than you might think. I'm going to go to the tables. They're in here somewhere. So I attached them to this set of notes too. Here we go. We're looking at T, degrees of freedom 6. We're looking for minus 1. So we're looking for 1. degrees of freedom 6. So 1 is between, are we with me? Yeah, we are. Okay, so 1 is between these two numbers. And so that means the tail probability is between these two numbers. So between 0.2 and 0.15 is the p-value, which isn't less than 0.05. Oh, less than 0.01, yeah. Ordinarily 0.05 would be what we'd use, but we're being forced to use 0.01. So write that here. P-value between, maybe I should mark it on here. Degrees of freedom was 6. Oh, we're down here even. It's 6, right? It's 6, yeah. So we're here. 0.2 and 0.2 and 0.15. 0.2 and 0.15. So less than 0.2, but bigger than 0.15. So we do not reject HO at alpha is equal to 0.01. The p-value is so much bigger than 0.01. It'd even be bigger than 0.05. And then it says compute a 95% confidence interval for the population mean difference for D. So that's X bar plus or minus T alpha over 2 S over root N. Let's check that. Got some formulas here. Didn't pull them out. Hang on. Back here. Somewhere around here. Here we go. So we'll have this sheet to work off of. Here's the confidence interval formula for matched pairs. We should just have one generally anyway. Here's the one, just the usual one for X bar. It's the same formula, identical formula. So you don't need both of them, but they're both there just in case you're used to looking at this. Here's the T for differences. Our mean that we were assuming, we're checking whether the mean could be 0. Okay. I'm going to go ahead and do this. We need the critical T value. It says 95%. So if it's 95%, that means alpha is 0.05. 95% says alpha is 0.05. Alpha over 2 is 0.025. So I'm going to go to degrees of freedom 6. Have any fun colors here? Where's my yellow stuff? Gone. Okay, we'll just stick with what we have. Degrees of freedom 6. We're looking for 0 to 5. That's over here. Where is it? Here we go. 0 to 5 is here. Okay, and we come down to degrees of freedom 6. .447. That's going to go there in the confidence interval formula. So that's 2.447. S was 0.526. N was 7 pairs. Square root of 7. X bar is negative 0.2 plus or minus. Making progress. And just start typing. Okay, minus 0.2, I say plus. 2.447 times 0.526 divided by the square root of 7. Double check all that. Looks all right. Go. So that's the top end, 0.286. So that was the plus. So 2.8648.2 like that. And then I'll go ahead and, that's just dirt on there, I'm hoping, isn't it? It's not a minus sign. And then we'll do the subtraction once. I'll go second, enter, type it again, and come back here, make that a minus sign. Go. Minus 0.68648, minus 0.68648, something. It's a lot of places. Okay. And then we would say to ourselves, what's interesting about that is this interval here, having pen issues today, that's for sure. That interval contains 0. I'll start throwing some pens away. So when a confidence interval contains 0 or contains a value, that means that value is a possibility for the thing you're trying to estimate. So that confidence interval would indicate that having a mean of 0 is possible, which is what the null hypothesis said. So you're not going to reject the null hypothesis. This is a 95% interval. And so it corresponds to a 5% level of significance. At that level, you would not reject the null hypothesis. And 0.01 is even more stringent. So if we had computed this interval first, we would have known that a 95% interval, if it contains 0, then if the null hypothesis says that the mean is 0, then a level alpha equals 0.05 test would fail to reject the null hypothesis because the interval says that 0 could be the mean, and that's what the null hypothesis says. So we did that. Okay, fine. I got all these sheets. We'll head down here. Oh, I was going to do that straight by calculator too. That's right. So we'll get out of here. Clear this. Okay. We can also go to stat tests and do a t-test using list 4. Because that's where our data is. So we go using data, the null hypothesis 0, list 4. And we want to do a two-sided test, it said. So not equal to is the alternative. And come down here and calculate. Oh, well, that brings up a story I should have told you. It says the p-value is 0.35. Wait a second here. This is just the tail probability. The tail probability. It's two-sided, though. So we have to double those. 0.4 and 0.3. Cool. So luckily I double checked it with my calculator and found out, hey, it's supposed to be 0.35. That's because it's a two-sided test. And you take the tail probability, which you get off the tables. And the tail probability is between 0.2 and 0.15. But you double that to get 0.4 and 0.3 for the p-value. It's even worse than we anticipated. More or less, this could easily just be random variation that we see between those, the x's and the y's, just randomly varying. One's not tending to be bigger than the other, pretty much at all. Oh, glad I caught that, because I've had this on tape now. Okay. Here we go. Here's another one. It's a this is, what is this? Just the hypothesis of mu1 less than mu2 at the alpha equals 0.05 level of significance for the given sample data. It's really not a very good question, but I took it out of our book. This is a two-sample t-test. We need independent samples. It doesn't tell you they're independent, so basically you couldn't do it, but that's fine. We'd also need normal distributions. It also doesn't say we have normal distributions, and the sample sizes aren't very big. Well, together, I guess ordinarily you add these two numbers together and get 21 as a proxy for the sample size, so moderate size sample. You still want to look to see if things are okay, approximately normal, and they don't ask us to do anything except compute it, so okay, fine. We're testing mu1 less than mu2, so the null hypothesis here is mu1 equals mu2, and the alternative is mu1 less than mu2. Okay. They're a little bit sloppy. This is actually one of their sample test questions, kind of sloppy way to do it, but okay, fine. But the t is x1 bar minus x2 bar, and then here would be mu1 minus mu2, but the null hypothesis makes that 0. And downstairs, I've got the square root. Now I've got the standard deviation. Divided by the sample sizes, first squared, and then kind of average, and we take the square root. And so we'll see what that is. I've got all the stuff I need there. So I'm not actually typing anything much in. So it's 96.6 minus 98.3, and downstairs 3.2 squared over 13, and then 2.5 squared over 8. And we'll check this. We'll type it out and then we'll check it on the calculator, because there's a way to type this stuff into the calculator too. So we'll go here, clear this, put some parentheses in there. 96.6 minus 98.3, do that. Divide that by this giant square root. 3.2 squared, come over, divided by 13, plus, 2.5, square that, come over, divide that by 8. That looks okay. I'm checking my exponents. One time I had a 5 up there. I couldn't figure out what went wrong, but it was a 5 instead of a 2. And you can't really see it. It's so tiny. I looked at it for like 5 minutes, couldn't find the problem. That's the wrong number. I knew it was. Okay, that looks all right though. Okay. So it says minus 1.357. We're using alpha equals 0.05. We'd have to get something like a 2 here. It's a less than, mu1 less than mu2. So since it's a less than alternative, the p-value is the less than side of the t. So here we have minus 1.357. The p-value is going to be on the left-hand side. So it's going to be the tiny tail probability corresponding to 1.357. The degrees of freedom, there's a formula for it. We can use the smaller of the sample size is minus 1, so 7, or we can let the calculator do it. Find the accurate. I'm having trouble here. Accurate? Two C's, I guess. Yeah, value. Okay. If we used 7 and we've got 1.357, now we're using 7. 1.357 shows up here. Here's my tail probability. This time this is a one-sided test. So the p-value is between those two values, between 0.1 and 0.15. Put it here. P-value between 0.1 and 0.15. Double check that with degrees of freedom 7. And we got 1.3. 0.1 and 0.15. Okay. And we're using alpha is 0.05. I can't, okay. Using alpha is 0.05 here. So we're going to fail to reject. Again. And I will make the calculator do it because I can. So stat test 2 sample t test. And then we're going to use things we've already given stats for that. And we start typing stuff. Okay, so X1 bar, 96.6. S1, 3.2, 13. And then X2 bar, 98.3. Hope it gets shown up this time. 2.5 and 8. And now it's a less than alternative. We never choose pooled. And we hit calculate. So we ought to get the t-value we had because that's not dependent on anything. Let's see what it says. No.
You put 25 instead of 2.5.
Thank you.
Yeah.
Oh, okay. Inside here. I got it. Test. It'll still be there. Look at that. Well, this time I beat the calculator by making a mistake in the calculator instead. Now we'll see what happens. Get down here. Okay, now we got the 1357. All is good. Here's the actual degrees of freedom in this case. It's really 17.72. But we know that doesn't make a huge difference. So just for a gut level check, we use the smaller of the one less of each sample size. That tells me everything else. Here's the p-value, 0.09. Because we had such a small approximate degrees of freedom, we didn't quite get the 0.09. We got between 0.1 and 0.15, a little bit larger. So using this, the smaller size of degrees of freedom tends to make the p-value inflate. Things look not as significant, but it's not a huge difference. It didn't make the 0.05 level. Either way, we're still good. And there we go. So that's how you handle that on the calculator. And thank you for pointing out I didn't type 2.5. I would have freaked out for at least 5 minutes. Then I would have gone back to life as usual. Okay. So what I'm going to do now is I'm going to stop recording for a minute.